So good afternoon to one and all present over here. It's my great pleasure to introduce today's our chief guest, Dr. P. Shanmugavadivu, Professor, Department of Computer Science and Application, Gandhigram Rural Institute, Dindikkal, Tamil Nadu. She has completed her Bachelor's of Science in 1987 from Kundavai Nachar Government Arts College for Women, Tanjavur, and M.Tech from Birla Institute of Technology and Science, Bilani, and also received PhD from Gandhigram Rural Institute. In addition to this, she has also completed MBA from Indira Gandhi National Open University. Her area of interest includes medical image analysis, digital image processing, parallel computing, healthcare data analytics, software engineering, content-based image retrieval. She has also completed several funded projects with an outlay of 2.4 crores from the funding agencies such as UGC, USIEF, DST SERB, and ICMR, etc. She has also received an award in Indo-US augmenting the curriculum of higher educational institutions with an online integrated cognitive-based employability skills assessment using signal and video analytics in 2015. She is also recognized as an Governor Chancellor nominee Planning and Monitoring Board from Mother Teresa University, Kodaikanal. Under her guidance, 10 students are awarded PhD and 9 are in the other. With such a distinguished background in 35 years of teaching and wealth of experience that continues to inspire and drive innovation, I request Dr. P. Shanmugavadivu ma'am to take off the dais. Thank you, ma'am.
அது இது மட்டும் இங்கே வச்சுக்கலாமா? இங்கே லேப்டாப் எப்படி வச்சுட்டா நான் இப்படி கூட பார்த்து எடுத்துருவேன். கேன் வி கீப் இட் ஹியர்? இது அதை இங்கே வச்சுக்கலாமா? அந்த வச்சுட்டா நான் திரும்பாமல் பார்த்து எடுத்துடலாம். Pleasant good afternoon to every one of you. Good afternoon, everyone. I take this opportunity to thank Madam for having invited me to be a part of this faculty development program. And I'm happy to come to this institution for the first time. I know this is one of the prestigious institutions, and it has got its own legacy, and I'm very happy that I'll be able to contribute something for the exercise they take in dissemination of knowledge and reaching the faculty of this computer science, ECE, and the related domain on the latest technology, right, to speak with. அதையுமே இங்கே வச்சுடுறீங்களா? அது வைக்க முடியுமா? Okay. So when we discussed about my special thanks to Mr. Gurunathan, I used to disturb him probably 8 o'clock, 9 o'clock, 10 o'clock about fixing the schedule, and he was very patient enough to take my calls. When we discussed about what could be the topic to be discussed, initially I thought of having a session on generative artificial intelligence, as already it was covered or to be covered by another resource person. I thought, let me take the essence of artificial intelligence in the light of machine learning and deep learning for image and signal processing. Sir, இதை இங்கே வைக்க முடியுங்களா? இதை இங்கே வைக்க முடியுங்களா? இது கூட யூஸ் பண்ணிக்கலாம். இது வேண்டாம், இது யூஸ் பண்ணுவோம். அது நம்ம அப் டவுன் மட்டும் தான் யூஸ் பண்ண போகிறோம். இல்லை, எனக்கு அதை இப்படி வச்சுட்டிங்கன்னா நான் அப்படியே பார்த்து படிச்சிருவேன். இல்லை, இப்படி பார்த்து படிக்கிறப்போ கஷ்டமாக இருக்கும். Sorry for the inconvenience. வருமா இவ்வளோ தூரம்? So this is the roadmap. This is how I have planned the sessions to be. Introduction to signal and image processing, then overview of ML and DL, role of machine learning in signal and image processing, then role of deep learning in signal and image processing, then applications of AL and ML in signal and image processing, then challenges and future trends. Right? We'll do one thing. இது எப்படி கொஞ்சம் திருப்பிக்கலாம். அது ஓகே தானே for capturing. Okay. So now let's begin with introduction to signal processing. I think this is like giving introduction about signal processing, and EC is like teaching alphabets to faculty members. So just to have a kind of continuity in the flow of the presentation. So this deals with analyzing, modifying and synthesizing signals. It can be in the form of audio form, or it can be in the video form, or the data that you receive from the sensors. Sensor data, that is to extract useful information to improve the quality as well as to enable further processing. Right? So now why do we have to talk about this signal and image processing together? Normally whenever there is a proposal or something, we say that this is introduction to image and signal processing, then essentials of image and signal processing. They are interwoven together because signal is the mother for image. Right? So when you represent any information in the form of a signal, it can also be visualized as an image. And in that sense, as there were a lot of advancements in terms of signal processing, then the research realm and the faculty members started working on signal and image processing together. So in most of the EC departments, they'll work both in signal as well as images. So this is like a twins, like signal and image. So the signal processing is not just handling signal. Apart from that, we just look into how best we can extract useful information from the signal, as well as how do we use that pattern or a kind of useful information that is present in the signal for further processing, for enhancing other actions, other operations. So it plays a crucial role in communication systems, medical diagnosis, multimedia processing. Now it's needless to mention artificial intelligence has become a revolutionary technology. So it covers any field that you name. It can be medicine, it can be finance, it can be e-commerce, and it can be agriculture, it can be drug design, or it can be medical diagnosis. You just name anything, it involves artificial intelligence. And the mobile that you use has got a lot of applications of artificial intelligence. So naturally, essentially, we have to take the flavor of artificial intelligence also when you talk about image and signal processing or signal and image processing. So what are the types of signal? It is analog signal and then digital signal. As you all know, when the pattern happens to be continuous in nature, it is analog, and when the pattern happens to be discrete in nature, it is called as digital. So what is the importance? And it enhances the signal quality for better communication and analysis, and then it is used in artificial intelligence, IoT, biomedical, multimedia applications. So now, what are the key operations that we can perform in signal processing? Now, whenever we talk about a signal, right, it may have different types of sources from where it is generated as well as it is being acquired, right? So between the process of generation of signal and the acquisition of signal, and there may be a lot of interferences that may lead to introduction of noise in the signal. So essentially, before you start processing any signal, we necessarily have to apply some filter mechanism so that you will be able to remove the noise and take the useful signal for further processing. So filtering is one of the important operations that we have to do when we talk about signal processing. So what do we do there? And we just remove the unwanted noise, right? What is the difference between a noise and a signal? Because in a bunch of signal, the noise will also appear as a signal. Am I right? So how do we distinguish between a noise and a signal which has some useful information or essential information? Yes? Filter? Frequency? Okay, and how do you decide that frequency should be a noise? So when you have series of signal information, right, when something is totally different from its neighbors, so that should represent a noise, right? When I'm talking in one flow, when there is a sudden noise of different wavelength, different frequency from somewhere, it is a noise. So noise is an irrelevant information in a given context. In a given context, noise is something which is irrelevant, which has got different frequency or different, as you say, different frequency or different pattern. So it is removing unwanted noise, like we have to apply denoising algorithms, like we have got n number of such algorithms which we can use for filtering. And then we have to think about signal transformation. So what is transformation? Converting a given data from one form to another form. Right? So now when I say that I have the signal in, say, Fourier transform, right? When we apply this algorithm Fourier transform and convert it from ordinary signal to some other signal, or you can convert the signal from one form into another by using wavelet transformation, and then you can use Haar transformation. There are a good number of transformation algorithms available. Why do we have to transform them? In order to do better processing. Right? So you have the text in your hand, textbook you have in your hand. For better reading, what do? You just take notes from the given set of textbooks. So then you just make yourself understand that now it is easy for me to read. So in such a way, when you transfer signal from one format to another format, that signifies that I will be able to handle the information hidden in the signal in a better way, or I will be able to understand the pattern that is hidden in the signal in a better way, right? That is the kind of understanding. So it is converting signal into different domains, say Fourier transform for frequency analysis, right? Suppose when you talk about this, especially this noise removal, right? Noise removal could be done in two different flavors. One is spatial domain operations, other one is frequency domain operation. For certain kind of noises, spatial domain operations may not be suitable. So in such cases, essentially you have to apply the algorithms only in the frequency domain. So frequency domain has got certain specific characteristics. So certain kind of operations are done well or performed well in frequency domain. Then the third category is called compression, right? So you know, when you store a signal, that is going to occupy a fair amount of storage space. So now I just want to have a mechanism by means of which I have to retain the data as such, retain the information as such, but I want to minimize the data requirement in terms of storage. So there are a lot of algorithms for compression. Now we can work on signal compression as well as image compression. So this is to like reduce the data size while preserving. That is very important. But of course, when we talk about compression, there are two types of compression where you can just think of compressing and then don't bother about the loss of information. There are certain kind of compressions where data preservation is very important. Yes or no? Yes. In the case of medical image related data, compression is very important. That is, you must be able to reverse the compressed data into the original form. In certain kind of things, like suppose if you take your photograph, digital photograph, right, and when you try to compress the size, suppose if you apply for a particular post or for certain program, they say that size should be 10 KB. right? At that time, what do? We try to compress the size of your photograph, and after that, when you want to reverse it, it is not possible, because that kind of compression is called as lossy compression, right? Some amount of information is being lost, but we may not be able to reverse it, and that kind of compression is called as lossy compression. But in certain kind of domains, like say medical image processing or signal where each bit of information is very essential, in such cases we have to go for lossless compression. So we have to preserve the information as such. So this is reducing data size while you preserve the data as such. So there are good number of algorithms available. MP3 just stands out, right? So though we try to develop good number of compression algorithms, we are not able to beat MP3 standard. Then the fourth one is feature extraction. Now we have done filtering, we have transformed the signal from one form to another form, we have compressed it. Why do we do all this kind of operations? Ultimately, I just want to find out certain pattern from the given signal, right? Suppose if it is ECG, what do the doctors look for? They just want to see whether the pattern is uniform or not uniform, whether it is erratic, right, or whether it is correct or not. So each and every signal is going to depict, or this is going to visualize certain information which can be used for some kind of interpretation. So in such cases, if we identify the important patterns in signals, example ECG peak, right, detection in heart monitoring is very important. So now we in the age of artificial intelligence, now we aim for 100% automation of understanding the signal, handling the signal, and reading the signal, and extracting information from the signal. In such cases, it's very important to focus on this feature extraction, where it plays a very important role. Suppose if you want to go for developing a model which can identify the presence of heart disorder or absence of heart disorder by means of automated mechanism. So what is needed? There should be a kind of system which can read the signal, understand the pattern, and say that whether it is systematic or whether it is erratic, right? So these are all the operations that are needed. Then applications of signal processing, we deal with speech and audio processing, image and video processing, then biomedical signal analysis, wireless communication, and IoT, because each of its input is being given in the form of signal, and then we use it in radar as well as for defense operations, and then for monitoring in traffics, like in suppose when you take for defense, in the case of defense, when there are airplanes, right, to be monitored, and to monitor whether the other countries airplanes are coming in such cases, this plays a very important role. So the first one, speech and audio processing. Signal processing enhances speech and audio quality by reducing background noise, improving improving the clarity, as well as enabling applications like voice assistant. I think most of you must be using Siri or Alexa, right, in your mobile phone. And we don't have patience to just go to your clock and then set the alarm. Suppose if you want to wake up by 4 o'clock. Come on Siri, set the alarm at 4 o'clock, right? It sets. So this is how we are getting tuned to the modern developments. In such cases, your voice is a signal, right, that has been synthesized by a software that is present in a mobile phone. It responds to, it understands your requirement, that has been converted, and the app is automatically getting enabled, and that is the required action is being set. So in such cases, what do? It tries to help us to use your signal in different kinds of applications, like the Siri, Alexa, and automatic speech recognition, that is called as ASR, and then real-time language translation systems. So after the intrusion of this artificial intelligence, this language translation has become very easy, right? You can try to listen to any kind of text or any kind of audio in any language. You just call for this language translator that's able to convert from one language to another language, from one regional language to another regional language. This is a kind of revolution, we could say, in terms of natural language processing, right? We never imagined it could be so simple to convert one text from another text, one voice to another language voice, and that has become very simple now. Okay, then image and video analysis, it is needless to mention, right? Advanced signal processing techniques like power object detection, facial recognition. So when we just move from speech and audio signals to image and video, now we think in terms of digital image and digital video. Right? So whatever be the signal that you have in the analog form is getting digitized, as all of you must be knowing. Now when a continuous signal or analog signal is given, and when that is taken for digitization, it involves two set of processes that you call as sampling and quantization. Right? So from the entire set of signal, it selects the sample points, and the intensity or amplitude in the specific points are being converted to the corresponding digital value, and the chosen points are being taken as the coordinates, digital coordinates, right? So that involves this sampling as well as quantization. So any given signal can be converted into, any given continuous information can be converted into digital form. So this image and video are no exception. So then advanced signal processing techniques, namely power object detection, then facial recognition and medical imaging, which allow applications such as self-driving car. Now this is in the news, right? Like this, the United States of America is coming out with driverless cars or automated cars, where there is not going to be any driver. You mentioned the designation, and with all accountability and reliability on a machine, we must be able to travel in such kind of cars, right? So now that has become order of the day now. Now the days are bygone, whether it will be able to work or whether to rely or not. It is already in operation. So self-driving cars or automated cars, driverless cars, and they all require object detection, right? So it must be able to identify the signboards, and it must be able to identify the objects in the middle, and suppose if there is any object obstructing the pathway of the automated car, it has to stop. It should know how to apply the brake. For all such kind of things, image processing plays a very important role. Then security surveillance, suppose if there is a car which is passing by in any toll, right, it is able to identify the car, and then the number plate, everything is being read. So that involves image and video analysis. And then in medical image processing, like I think you all must be doing research with CT scan, PET scan, right, MRI scan, mammogram images. So in all this kind of operations, we essentially require these kind of image and video processing operations. Then biomedical signal analysis, this helps in monitoring, diagnosing, predicting diseases by what do we do that? Like we just look into the different kinds of signal, like electrocardiogram for heart health, right, EEG, and there are these kind of different kinds of signals are available. And this arrhythmias, right, this is one of the important upcoming research area. Many are working on it. And then this epilepsy, suddenly they get this kind of, they Tamil call this as kakai valipu, right? So that kind of operations, you have to measure the signals created by the brain, right? And even this heart disease, then this arrhythmia, all these things, at least we can predict whether it will happen or not. Whereas this epilepsy is concerned, now no one could predict when that person will get that kind of symptoms. So now researchers are working on this epilepsy, and they try to see whether it is possible from the brain signal to predict the occurrence of epilepsy or not. And there are a good number of neurological applications, right, for all this kind of operations. So now, previously it is just speech is an audio signal. Now we talk about biomedical signal analysis related to your brain, related to your heart, related to your lungs, right, liver, its operations, kidney. When you get those kind of information, we call them as biomedical signal and the respective analysis. Then the next one is wireless communication and IoT. And at every point of this, here it is, when you talk about wired communication, wireless communication is another component of signal processing. So here modern wireless networks including 5G, right, Wi-Fi, IoT devices rely especially on the signal processing for efficient data transmission, data acquisition, noise reduction, channel optimization, then route optimization, right, then suppose if the signal is getting weakened, they have to strengthen the signal. There are a lot of operations that is ensuring faster and more reliable communications, right, in terms of smart home, then autonomous systems as well as industrial automation. Then the next one is Then radar and defense. Now radar signal processing is it's a kind of critical for target tracking, weather forecasting, and then for military operations. In most of the military operations they use this radar, right, for identification of incoming objects, and enabling applications such as air traffic control, missile guidance, disaster prediction, then any kind of so the weather forecasting, whether there is going to be a cyclone or not, whether there is going to be a kind of tsunami, kind of natural calamities. In all those kind of operations we have to, suppose if they want to check if it is earthquake prone area, right, so they have to analyze the seismic signals, right, so whether it is a normal or suddenly if there is any change. So any kind of weather forecasting could be done with the help of these kind of signal and image processing. So disaster prediction, including like Doppler radar, there are different kinds of options that are going on. Okay, so then this introduction to image processing, rather it is digital image processing. Now image processing is a collection of techniques used for manipulation analysis of images to extract useful or valuable information. Okay. Why do we call it as useful or valuable information? Suppose if I try to develop a model for face recognition, right? And of course we have biometric, your mobile phones must be having your face recognition option, right? We use it as a kind of a security code, right? You just look into your mobile phone, you are able to gain access. So how does it happen? Does the mobile phone, does the software, the respective software, try to remember your entire face? No. It's not essential as well, right? It only requires your eyes, then your nose, and then the lips, and then this pattern of your face. Okay, that is just sufficient. So whenever there is any kind of image processing, right, it is very essential that we are not going to grab the entire set of data in the image, rather we try to extract the most important features. Right, if it is your face, it is going to be your eyes, nose, mouth, then special features. And when you just look at a person, look at the features of a person, right? We just look into the eyes, face, eyebrow, then the pattern of your jaw, pattern of your cheek. Only these kind of information are being taken. And this is the same when you go for plant identification, or this vehicle identification, or animal identification, any kind of thing. It is not going to take the entire image, rather it just only takes the specific set of features which are necessary to identify a person, right? That is what our brain also does, right? When you look at a person, right, it formulates this kind of feature extraction from each and every object, and that is being registered in our brain. Okay, so if the occurrence of looking at the object is very frequent, it is very vivid, what happens is the brain is able to remember those features and associates it with the person or the place where we met or any kind of incident. And if suppose if the person comes with a different attire or in a different occasion, but still your brain is able to correlate the pattern it has got in the brain with the features of the person that you are seeing, right? So if it is in your forebrain, then you are able to remember it. And suppose it has been pushed to your back brain, then you are not able to remember, but you have a kind of sense. I have seen this person somewhere, I have seen this person somewhere. Probably when your neurons become active, you are able to remember, yes, I have seen this person here, this is the name of the person. Depending upon the kind of the health aspect of the neuron, you are able to remember. Okay. So it involves performing operations on an image to enhance the quality, right? This is very important in the case of digital image processing. Before you could start extracting the information or extracting the features from a given image, it's very important to improve the quality of the image. That you call as pre-processing of images, right? So what do you mean by pre-processing? First of all, if there is any noise in the image, that noise should be removed, number one. Right? We have got good number of filters like mean filter, median filter, adaptive filter. There are good number of filters available. So you can use those kind of filters with the help of which you can remove noise. That is one aspect. So once noise is removed, sometimes to make the algorithm to understand the given image or to recognize the given image, the most important thing is it has to have contrast. it has to have contrast, right? Suppose if there is no kind of contrast in the image, right, it's very hard to identify the features, right? Suppose if the image is very hazy, right, if it is smudged, then the algorithm will not be able to identify where the eyes are, what are the important features to be taken from the image. So in such cases, you have to apply the methods called image enhancement techniques, wherein we aim to increase or improve optimally the contrast or brightness of the image. Right? So this image enhancement always focuses on contrast improvement as well as brightness improvement. That is what you do, right, with respect to your photographs that you want to edit in your mobile phones. Right? You try to improve the contrast, you try to improve the brightness, with the help of which you try to change or try to improve the appearance of a given image. So this is what you call in medical image processing or any kind of image processing as image enhancement techniques. So we have to do this image enhancement, right? And after that, like when you want to extract the features, we have to identify the edges, contours or borders of those features. That's very important. So for that purpose, we do edge detection or edge identification. So once the edges are being detected, then you can connect those edges and try to take the features, and that aspect is called as segmentation. Right? It's called as image segmentation. So once the features are being extracted, then you can apply respective algorithm, and then you can go for identification of an image or identification of a disease, identification of an object, then classification of object, categorization of object. You can do a lot of wonders once you do all this kind of pre-processing operation. And these kind of operations like noise removal is called as image restoration, right? What is restoration? Now, because of the introduction of noise in the image, the quality has got degraded. See, now we try to change the quality of noise to a better form, so we try to restore the quality, and hence it is called as image restoration. So image restoration, image enhancement, edge detection, segmentation, once you do with all this kind of operations, you can go for advanced level of operations, right? Image registration. So you have a package of such kind of algorithms under image processing. That's why we call image processing as a kind of aggregation of good number of algorithms. So it's a collection of technique used to manipulate and analyze images to extract valuable information. So it involves performing operations on an image to enhance quality, detect patterns, recognize objects, and convert visual data into useful format for further analysis, right? So this is the sequence. So image processing is widely used in various domains, including medicine, then any kind of security that we want to enforce, then robotics, and we have got a lot of such kind of in entertainment, right, to improve the quality, and this has become kind of very challenging task earlier, but with the availability of good number of deep learning models, now you don't have to go for these kind of pre-processing, everything will be done by deep learning models. So now the key functions in digital image processing, first one is pre-processing, second one is feature extraction, then segmentation, classification and recognition, then compression and storage. So these are all the major essential what do you call as approaches, right, that we do with respect to medical image, digital image processing or medical image processing. So then what do we do there? We just go for noise removal, then we perform, we have already talked about, right, what is meant by noise removal, and then contrast enhancement, then edge detection. Then with respect to this feature extraction, we go for shape identification. Suppose if you want to identify the fruits, if there is a basket wherein you want to identify the fruits, what kind of fruit it is. You have an assorted collection of fruits, then you have to go by the shape, their color, their texture. So you have to extract all those kind of information. So that is being called as shape feature extraction. Then texture extraction, right? Suppose if you just take the grapefruit or apple fruit, when you compare it with pineapple, there is a difference in the texture, right? As you feel it, like manually, the same thing should be done with the computer vision. So texture identification, and then color features, right? Then how do you do with segmentation? The segmentation is normally done. It's a very simple approach wherein you set a threshold. What is a threshold? In general, what is a threshold? it's a tolerable level, right? Suppose if you pick up quarrel with your friend at one point, this is my threshold level, please don't trigger me beyond this, right? So after that, your attitude may change. Now you are very calm. So especially with respect to segmentation, we set a threshold based on which, suppose if the intensity happens to be of this threshold, then we categorize them as good tissues. If it is not falling within that range, it is taken as a diseased tissue, something like that, as an example. So threshold plays a very important role in separating the foreground objects from the background. Right? Suppose if we have, for instance, a mammogram image, right, to identify the breast cancer. You have to identify where do we have the tumor, where do we have the microcalcifications. So segmentation aims to extract the forefront objects or foreground objects from the background. So you set a threshold, right? Suppose if the value happens to be above this, right, that should be categorized as background. If it is below that, that should be taken as foreground. So we try to separate them, segment them, and we try to extract them. So it is called as thresholding based segmentation. Then we go for region based, we can do, then edge based we can do. There are different kinds of approaches for that. Then once we segment it, right, now we have segmented all the objects, for instance, in a mammogram image. So now we have to go for classification, which regions or which objects which are segmented or representing presence of breast cancer or absence of breast cancer, whether its microcalcification is good or malignant, benign, all those kind of classifications are to be done. So that's the next one. That's the main purpose of performing all this kind of operations like pre-processing, feature extraction, segmentation. What is the target? To go in for object identification or classification. So that categorizes the image. There are a good number of algorithms available. Support vector machine, right? Only now we talk at length about support vector machine, but when you go back to the research articles published in 1960, 1970, they have used this SVM, right? So SVM is given in a different flavor in terms of artificial intelligence, easy to use, but these are all the methods which are already available, which have been enormously explored by our researchers years back. Then the next one is facial recognition, detect and verifies the face. For example, FaceNet is one model which performs for identification of faces. Then pattern recognition identifies the repetitive structures like fingerprints, right? You suppose if you have your fingerprint as the security for access to your mobile phone, right? If you put your thumb impression, it's able to recognize the pattern. When I do it with your mobile phone, pattern is not matching. It says pattern mismatch. So it has been trained to understand the pattern. So it's able to go with respect to pattern identification. So identifies repetitive structures like fingerprints, then barcode, etc. Then compression storage, already we have seen, right? What is lossy compression, what is lossless compression? Lossy compression is the one where, suppose when you compress the image, you cannot get back the original image. The lost is lost. Lossless compression is you will be able to reverse it. They use some dictionary, they use some vector code based on which they will be able to bring back the original one. So then the applications of signal and image processing, and the most important sector where we use this in medical image analysis. So this medical image processing analyzes the diagnostic images like X-ray, CT scan, you name any kind of medical image, right? So it's able to help us to process it, helping like doctors to detect diseases in an easier manner or to validate their idea about identification of diseases. So what do we do here also? As we do enhancement in the images, now we can perform CT, MRI enhancement could be done. Then as we identify the objects, then tumor detection could be done. So as we identify a person, we can identify the anomalies in the given image, or we can go for automatic diagnosis of any disease. So these are all the new upcoming operations that have become viable with the support of artificial intelligence. So then, as we talk about facial recognition, you have to detect it, analyze it, identify, and then authorize it. So this is the sequence. So facial recognition technology is widely used for security authentication. and law enforcement. So here, then you can use it for biomedical security, then emotion recognition, right, and then crime prevention or crime detection or crime analysis, and all those kind of things we apply this. So it's needless to mention, in EC department, I think few of you must be working in satellite imaging, right? Then remote sensing. Now you take the satellite image, try to identify what is the dense of habitation, so what is the dense of forestation, what is the degree of deforestation, right, what is the level of urbanization, and these kind of activities could be identified by going for time series analysis of this kind of satellite images of a particular place. So satellite imagery is used for environmental monitoring as well as disaster management in defense applications and many more. And to name a few, you can use it for weather forecasting. AI processes satellite image to predict hurricane and then storms, as well as any kind of climatic changes could be identified in advance. And then deforestation is one of the important threat for the humankind, right? Because we try to urbanize every place by cutting off all the trees. Now that is going to have very major impact on the climatic changes and the weather changes. So in such cases, even the government wants to find out what was the level of deforestation, and then how we can go for afforestation, how we can improve the green cover in a given village or in a given city. So the deforestation monitoring, remote sensing detects the kind of illegal, even suppose if there is illegal encroachment in a particular place, that can even be identified, and helps for monitoring, and then helps for planning for a city, right? Suppose if they want to decide in what are the places they have to go for a massive plantation of saplings, right, in order to increase the social forest, then they have to take the satellite image, find out what are the areas where there are no green covers, and then they try to plan for it. Then disaster management, we spoke earlier. Then agriculture and land use analysis. This is one of the important areas. Now, suppose if you want to work in urban planning, right, or if you want to get involved in smart city planning, in such cases, you have to use the satellite image to find out what is the area where agriculture was used, can we revive it, and what is the area to be allotted for habitation. All these things can be done with the help of satellite images. Then industrial automation as well as manufacturing. Image processing is critical for quality control, and then to go for identifying automatic detection of defects, right, in a particular plant. Suppose there is any leakage, if there is some dysfunction of a particular unit, that could be done with the support of computer vision, and process automation in manufacturing. Then automated detection of defects present in a given industrial setup, and then assembly line monitoring, that is cameras analyze real time footage of any given device or any given instrument to ensure precision in the process of manufacturing in different levels of manufacturing. Then barcode and QR code recognition, even for digital payments, we use QR code, right? So these all have become order of the day. Automated scanning for inventory management and logistics. So then augmented reality and computer vision. See, now whenever we use this image processing, computer vision has become an inevitable component, right? So as you have biological vision, you use your eyes and then try to identify the objects, right? Try to identify whatever there is in front of you. If the same kind of ability could be fixed with machines, computers, it is called as computer vision. So this is augmented reality and computer vision is one of the outgrowth of digital image processing. So here AR integrates digital objects into real world environment using image processing as well as computer vision. So then real time object tracking. See, now suppose if you say that if you board in a train, right, and if your relative or someone has to pick you up, you are starting from Pollachi and you are expected to be picked up by someone at Chennai. So what happens now? You have got a provision where your train can be tracked, right? They'll say that at this point now where you are, when are you expected to reach. So these kind of tracking is possible. There are with different satellites and then with mobile devices, mobile communication. They are able to track the objects and they try to put them all together. So this is real-time object detection. So used in gaming, right, and in many kind of operations, virtual shopping, and then interactive applications. Then medical AR, augmented reality application. Surgeons use AR, augmented reality is being used as a kind of complementary mechanism, right? We don't use AR to perform the real kind of operation. This is used as a complementary tool for performing operation, and that helps to enhance the visualization of internal organs when they do the surgery. And then automative AR, heads-on displays, like when you want to learn vehicle, or when you want to have some kind of research in the vehicle and its operation, they use this augmented reality. Instead of just sitting on a vehicle and driving a vehicle, they just use this AR environment in a single room. They can sit and then increase the speed. They can apply for a brake in a harsh way and try to see what is the impact of, suppose before the release of any new vehicle, they apply all these things in terms of augmented reality. So heads-up displays in a vehicle provide, they can go for navigation as well as safety alerts could be identified. So these are all kind of images where you can just identify what is the role of this, like a computer vision algorithm for crack detection. Suppose if there is a kind of atomic power plant, right, there's a very small crack, then that will be very disastrous. So in such cases, we are able to identify where the crack is, right? So then cloud computing and storage, it's order of the day. When you're working with deep learning algorithms, then we go for getting storage from the cloud, then we go for getting platforms from the cloud. That's happening. Then cellular and local area network, like we get connected with different devices and perform. And this augmented reality for we can go for crowd detection, then some kind of identification of some fault in a given device. And then in the case of automated device, it just takes a decision. Suppose if a crack is being identified in an atomic power plant, then it identifies that and it takes it to be a kind of a disastrous one. Then information is being passed on to the person who has to take remedial measure to mitigate this matter, right? So it takes decision spontaneously and it is able to communicate to the appropriate person, and it is going a long way with the help of this augmented reality, image processing as well as artificial intelligence. So now this artificial intelligence, this refers to this simulation of human intelligence in machine that are programmed or that are being used to think, learn and make decisions like human being. Now, how many of you already have some kind of knowledge about artificial intelligence? If not, how many of you do not have basic knowledge about artificial intelligence? How many of you have already started working with artificial intelligence? Most of you must be using, right? Okay. How do we learn? All of you must be knowing artificial intelligence models learn. They take decisions, they identify objects, they make predictions by learning, right? How do we learn? Me? Exactly. Okay. See, from the childhood, we learn first by observation, right? And then we learn by our parents teach us, this is a bottle, right? This is a chair. We are being taught. And then, as you say, like we are given a lot of opportunities to reinforce our understanding. So learning happens as a conscious process or subconscious process or unconscious process, and the learning happens continuously, as a result of which there is a knowledge base in your brain, in our brain rather. So whatever we have seen, whatever we have learned is being stored in the brain. So depending upon the requirement, very few things we use repetitively and certain things we just forget, right? Suppose if I ask you, could you please solve Schrodinger's equation? We cannot, but we can refer and then do it. But instantaneously we cannot, because it's bygone days where we learned about Schrodinger's equation and then Van der Waals equation. All those things we have forgotten, though we have learned. So there are certain things which are vivid in our memory, certain things we may have to refer and then understand and then recollect. Certain things we may not be able to even recollect at all. So ultimately, your brain learns through experience. We experience, right? You look at an object, when you look at an object, it's an experience to you. When you hear something, when your parent says, say amma, say appa, it's an experience. You are getting it and your brain receives information through visual or through sensory organs. Lot of information is being given to the brain, then brain stores that as a pattern. I know if it's a bottle, it should be of this shape. Right? It can have different variations as well. It can be in the form of a bottle, or it can be a plastic container, it can be a tumbler, right? Tumbler kind of thing with a lid. So my brain has understood now how to recognize an object, how to identify an object, how to understand when someone talks, right? How to respond when someone talks. So this has happened through a process of experiential learning, right? It happens through a process of experiential learning. That learning could be a formal learning or it could be an informal learning. Right? So it is not that every day when we were when in the childhood days, when we were children, it's not that you had a classroom where your mom makes you sit in the class, right? This is the first star. I'm going to teach you how to speak. Next time I'm going to teach you how to identify the object. No, right? It happened as a spontaneous, continuous process. We have learnt all those things through an informal manner. So whether it is formal or informal, your brain understands the patterns. And for a bottle, what is the pattern? To talk, what is the pattern? When you hear, it synthesizes the information and understands the meaning. When you are not interested, it doesn't receive anything. Like you can just sit here and pretend as if you are listening, but your brain is not going to receive anything. So it all depends, right? It depending on your reception of your brain, things happen. So now I think all of you must be knowing about the story of birth of artificial intelligence. John McCarthy, he was the one who coined the word artificial intelligence when he wanted to organize a winter school to explore the possibility of coming out with the concept of artificial intelligence. He gave the word artificial intelligence. So he is called as father of artificial intelligence. So according to this Merriam-Webster dictionary, it defines artificial intelligence as a branch of computer science that deals with simulation of intelligent behavior in computers. Right? We simulate. We are biological intelligent living beings. Now we try to simulate this biological intelligence in the form of artificial intelligence, right? Ours is natural intelligence, and the one which is simulated in a computer is artificial intelligence. Now what do we do with our intelligence? What all could we do with our intelligence? Exactly, we make decisions. Foremost thing, only after you grow and when you become conscious of your decisions, conscious of what you are doing, we make decisions. Even prior to that, when you were very young, right, you try to repeat whatever your parents say, right? And this is what you call as you try to understand and translate, right? Your brain translates what your parent says. Come on, come sit and eat. It receives it and you understand, then you respond to it, right? So you are able to understand the language, right? What is that? Understanding a language? Natural language processing, right? So that's how the emergence of natural language processing came in. So whatever you could do with respect to language, with respect to understanding language, it could be done by a machine. So simulation of your language understanding, language translation. So then you identify the object. We ask the children, where is the fan? They look up and then show. Right? Where is the table? They just show the table. So what is that? Vision. Right? So what does the AI do? Computer vision. Right? So it's able to simulate whatever vision we have in the form of computer vision. Right? That is what you call as object detection, object identification, object recognition, object classification. Right? Suppose if you give a child with a bag of balls, then it will be able to identify the colors and then take out all red color balls separately, all yellow color balls separately. What is it? Object classification, object categorization. Right? And then what else could we do? When you look at a person, as you said, when you look at a person without any kind of introduction, without any knowledge, we make some perceptions, right? We come out with some kind of conclusion. What is it called? Visual perception, right? So the visual perception could be done by a machine, right? And then what else we do? We predict about a character of a person, right? What kind of person he, by looking at me, probably would have thought, I'm a serious person, or I'm a very soft person or aggressive person, right? The same thing could be done with the computers, right? We go for that is what you call as, you have recommender system, right, where you can find what kind of person he or she is, what is the nature of a person, sentiment analysis that you do, right? So sentiment analysis is being done as you decide about a nature of a person. Sentiment analysis could be done on the person's attitude and the attributes of a person. And then suppose if it is very hot, you say that probably this week we may get rain, right? What is it? Prediction. So weather forecasting, weather prediction, then disaster prediction could be done by the machine. So suppose if a person goes to a doctor, then doctor says, what are your symptoms like? Right? So doctor, I had headache yesterday. Today I'm having running nose. Today I have this temperature. So all things are being taken into consideration. Then the doctor takes these as the input, concludes and writes a prescription. What is this? Decision making, right? Doctor takes a decision. So the expert system are able to take decisions, right? And they are able to provide solutions to you. So this computer vision, prediction, then sentiment analysis, recommender system, all these things, whatever that we could do with our brain is possible with the support of artificial intelligent algorithms, right? So that is why we say that it is a branch of computer science that deals with simulation of intelligent behavior of human being, right, in computers, and the capability of machine to imitate intelligent human behavior as we discussed, right? Language translation, computer vision, perception, decision making, all those things. So then we can just go further into this AI. It's a branch of science that assists machines to find solutions to complex problems in a more human kind of approach, right? So as we approach the problem, as we understand the problem, right? How do you identify a person? By looking at the features. So how does an AI model identify a person? How does your mobile phone identify? It takes the salient features and does it. Then it is a future of next generation technology. Now we talk about Gen AI, right? Then next gen beta, next gen alpha. So these are all kind of revolution of improvements, developments in the technology. So this is going to be this AI, of course, is the foundation stone. That is the keystone for the latest developments that are taking place in the realm of artificial intelligence. So this is one of the fastest growing and cutting edge technologies, of course, right? There is no doubt about it. Then it encompasses a variety of disciplines like you just name any kind of discipline, say medicine or finance or engineering, any kind of. Now, all of you must be knowing this personalized learning. I think you all must have heard about personalized learning. Now, every teacher should identify the learning potential of a student, right? And then they should be categorized as fast learner, medium learner, slow learner, poor learner. So now when I just come to the class and teach to the entire class, then I am not doing justice to my students, because everyone in the class will not be able to understand the kind of content that I deliver altogether in a uniform manner. So what do we have to do? You have to have a kind of categorization of content that can suit the requirement of learning aptitude of a student. Right? So with the support of artificial intelligence, the future is going to be, there is going to be a lot of transformations, lot of paradigm shift in the case of teaching learning, and this personalized learning is going to be one of the pivotal points wherein artificial intelligence is going to play a very important role. So you name any kind of thing, you take weather forecasting, you take weather monitoring, then agriculture, right, disaster management, then smart city development. In all these kind of things we have got artificial intelligence. So has redefined the art of computing for problem solving. Of course, we were meddling with traditional computing as well as object-oriented computing. Now there is a big transformation. We are moving to AI-based computing, has brought a paradigm shift and then offers a spectrum of computing models for problem solving. We have got multiple number of models for machine learning as well as deep learning. So we have a good package of, is not well? Are you not all right? I'm asking. Okay. So then it is capable of handling big data. Now this big data is a big problem with respect to traditional computing models as well as object oriented model. But now suppose when you take sensor data, it is going to be voluminous, right? When you take medical data, it is going to be voluminous. But thanks to this artificial intelligence model, they have got a provision to handle the big data. So now they have an edge over the rest of the models, and once the model is developed, we don't have to interfere at any point of time. So that becomes 100% automatic and there is no need for human intervention, and then AI is ideally suitable for interdisciplinary problems, right? You can pick up, you can join hands with physics, chemistry, mathematics, even social sciences, management, business administration. There are good number of problems available. Okay. So now as you just look into the realm of this artificial intelligence is a superset, right, which encompasses machine learning, deep learning. So machine learning is a branch of artificial intelligence and deep learning is an extension of machine learning, and they revolve around the data science, because without data there is no artificial intelligence, right? Suppose if we don't have any data about the surrounding, about the objects, about the people who have taught us, then our knowledge is zero. So likewise, this data is the pivotal point around which all these models are revolving. So data science deals with how to understand the data. Suppose when I have a data set for say for instance for heart disease. Okay, now I am going to develop a model, I am going to automate the detection of heart disease, cardiovascular disease. In such case, what is very important, I am going to make the model to learn the detection of heart disease. So when the model has to learn about the detection of heart disease, what's important? The suitability of data, exactly, right? Then the reliability of data, right? The authenticity of data. So the data has to possess the essential information which can make the model to understand how to go for disease diagnosis, how to go for detection of cardiovascular disease in a given patient, yes or no, right? So data is very, very important one. If there is no data, if the data is not proper, if the data is not a balanced one, then the model cannot produce reliable results, right? So for your kind information, please take my words. When you want to work with artificial intelligent models, the first and the foremost thing that you have to do is what? What should we do? Suppose if you go to a doctor And doctor says, okay, check the temperature. No, doctor, I don't want to be checked for my temperature. Okay. Are you having headache? No, doctor, I don't want to tell whether I have headache or not, right? Are you having any running nose? No idea. How will the doctor be able to recognize whether we have some problem or not? Right? So, your data has to have the essential information which will help the model to understand what is to be read from the data. Number one, right? Then, when you are making the model to learn something, then it has to have data from different kinds of sources. Right? Suppose if you are going to develop a model to identify cardiovascular problem for any age group, right? But if I am going to train the model only with the age group of say 5 to 15, then the model will not be able to correlate the understanding of cardiovascular disease for any age group beyond 15 based on the data you have given between 5 and 15. Right? So, in such cases what happens is your model gets biased. So, bias is a very big threat for artificial intelligence models, right? At times we do, right? We teachers, suppose when a student who always gets 90%, 95%, right? So, when we take the paper, we start with the assumption that she or he is going to score 95%. Even if there is nothing there, we don't have any heart to reduce the mark, we give the marks. So, it's a bias. Likewise, the model, when you give only a subset of data which is not a balanced one, then the model has got every risk of understanding the patterns wrongly. Okay? So, for any kind of machine operation, it is garbage in, garbage out. Right? Whatever that you give becomes the basis for learning, right? For problem solving. So, and whenever you start with machine learning, deep learning, what is the first question we ask? What is the data set that you use? Right? So, how good it is? So, how many instances do you have? Does it have 2,000, 3,000 records, 5,000 records? In such cases, you have to ensure that you have to apply EDA, exploratory data analysis techniques, right? To validate whether your data is intact enough to be given for machine learning or not. Are you getting my point? So, this exploratory data analysis will be able to help us. What are the lacuna that are present in the data, right? If there are some lacuna, how best we can rectify it? So, there are good number of data visualization techniques using which we will be able to identify the defects which are present in the data. Okay. So, this machine learning, data science produces lot of insights about the data, right? And the second one is machine learning produces predictions, classification, identification, detection, etc. And then the third one is artificial intelligence is the overall umbrella within which we have all these components that produces actions. So, then deep learning is used on like images, videos. Now, machine learning algorithms can be used on data also, like I think you must have come across CSV data, right, comma separated values data. But in the case of deep learning, we preferably use images, right? Of course, image can be converted into data and data can be converted into image, but whatever it is, these deep learning models preferably work on signals, then images, videos, etc. So, it covers, but when you want to work with machine learning, it is important to understand the basics of statistics and probability, because statistics and probability is the baseline for most of the machine learning and deep learning models. Okay, you should know what is convolution operation. You should know what is meant by summation of weights and the respective inputs. So, these are all very simple mathematics, right? And please do trust my words. Learning the theory of machine learning or deep learning is much harder when compared to the hands-on. Right, there it is just you have to put the data wherever it is needed. You have to change the parameters, you just get the value, result. Okay. So, at times, and this is at another point to be kept in your mind, because artificial intelligence is very attractive, because artificial intelligence is order of the technologies, doesn't mean that you have to apply only artificial intelligence model for problem solving. right? So the data and the problem that you have in your hand should have viable scope to be solved by artificial intelligence. Okay, so that's very, very important. So only when you are convinced, right, only when you are very certain that this problem has to be solved by artificial intelligence and not suitable for traditional computing or object-oriented computing, then you can think of artificial intelligence. Otherwise, you should not give popcorn to an elephant, right? And you cannot give popcorn to an ant as well. Okay, so there should be a kind of balance between whatever that you want to do with respect to the capability of the algorithms. So if you're not sure of this, right, probably the artificial intelligence models which are capable of giving 99% accuracy, 99.9% accuracy, cannot give good results. You may get 40% accuracy, you may get 30% accuracy, so that becomes a problem. So you have to understand the crux of this problem. It is not with the algorithm, it is not with the data, it is with the kind of data that you have given, right? Right. So it involves some amount of statistics, and then you have to know what is meant by this linear algebra, right? Then probability. Mathematics is very important, programming aspects, then it involves then data engineering, right? Then software engineering, millions lines of operations, etc. Okay. So now this is the overview of machine learning and deep learning. This involves machine learning, deep learning, two major classification that involves natural language processing, neural network, computer vision. And then you can see here, this machine learning is being categorized into supervised learning, unsupervised learning, then reinforcement learning and semi-supervised learning. Okay, I'll just give you a small information about what is meant by supervised learning. I think all of you must be having some knowledge about supervised learning. Okay, when your data set contains both input as well as output, the output is called as target variable and the values of the output is called as target value, right? When you have data set, suppose if there are 10 patients data, along with that when the output happens to be the person is healthy, the person is unhealthy, the person is moderately healthy. So this is the outcome, right? So when your data contains both input as well as output value, then for such kind of data we can apply supervised learning. So you supervise the model, see this is the input, that means this is the output. So what do you do in the class? You teach the students, when I ask this kind of question, you have to answer this way. You are guiding the students, right, based on what you have taught and what you are going to ask. Now in the case of, suppose if they go for any kind of competitive examinations, they are not sure about, they know the pattern, but what kind of question? Nobody has taught us, this is what I am going to teach, this is what I am going to ask. It's open-ended kind of thing. So when you have the data set with both input and output, all the input variables are being called as independent variables and the output variable is called as dependent variable, because to decide a person is healthy or not, you have to look into the input data. Right, whereas input data is depending on the output data, but output data depends on the input data. So all the input parameters are being called as input variables and the target variable, that is output variable, is called as dependent because it gets a value based on the input parameters. The second one is called as unsupervised learning. See, in all the occasions we are not going to identify something. We are not going to go for regression, getting some value for the given data. In certain cases, you go for categorization, classification. Right? Suppose if I give some 2000 mammogram images, right? It has to categorize them into, so this is breast cancer image, this is not a breast cancer image, this is malignant image, this is benign image. In such cases, you are not identifying something, right? You are not identifying something, rather you find the similarity between the given set of data. Based on the similarity, you formulate groups. Right? So all that which are within the group will have the maximum similarity. As you compare the similarity between one group and the other group, the similarity will be lesser and dissimilarity will be more. Am I right? In such cases, we don't have to have any output variable. So all your classification, clustering algorithms are being called as unsupervised learning algorithms. Then sir made a mention about reinforcement learning, right? See, now you have a model, right? You have, in the case of supervised learning, I start with the input, then there is a processing aspect, processing part. That is, we have the model, we make the model to learn about identification of disease, identification of language, translation of a given sentence, then you have the output. Okay, so now the flow of information is from the first input layer to the output layer. So it is forward, right? So this kind of operation is being called as, forward learning, right? Forward propagation. Right? So this is only one directional. In some cases, I get some output. Suppose if you take a student, right? You have conducted one test, right? You see the marks. The marks are not up to the expectation. Then what do? You go for retest. You tell the student, this time you have not done well, right? If you don't pass next time, you are going to get a fail mark. You are giving a caution. Whereas when there is another student who has got 95%, what do you say? You have done excellently well, you have to aim for 100%. So you are giving a kind of reward. So at that point of time, the one who is not performing well is given a caution that he or she should perform well in the next test. The other one, we are just promoting that you are going in the right path, you just go ahead and aim for the better marks, right? In the similar way, what happens is, in certain kind of networks, we call them as back propagation operation. Right? Whatever that you get after the output is being propagated back so that the process of computation is getting fine-tuned. Right? It understands. It has got certain set of parameters based on which the output is being arrived at. Okay. So now, suppose if you have a student who always gets 100 marks. Right? In one test, he or she has got 95 marks. What do? You call the student. See, at this point, you have missed it. Right? Here, you have done something wrong. Right? Had you done these things properly, probably you would have got 100 marks. So, like that, you are going to make the model to understand where it has done something wrong, where it is going correct. In such cases, we call that kind of learning as reinforcement learning. We reinforce every time when it does correctly and whenever it does wrongly, right? Whenever it does correctly, it gives a component called reward that makes the model to understand it is performing well. When it is not performing well, there is one component called penalty that makes what does it do? The weights that are given for the input parameters will be changed, will be adjusted, right? So this kind of operation is called as reinforcement learning. So it makes the model itself to understand how to perform better till it is getting fine-tuned. Then the last one is called a semi-supervised learning, where it is a kind of integration of supervised as well as unsupervised learning. Okay, so this machine learning only have got these classifications as supervised, unsupervised, reinforcement, semi-supervised. Apart from that, under artificial intelligence, we have got deep learning approaches, then natural language processing, neural network, as well as computer vision. So now this is the entire process. We call this as generic steps in artificial intelligence. I wonder how many of you will be able to read from there. Yes? Okay. So the first one is, I think I'll be able to reach you. So the first one, what is given? It is define the process. You have to define what is this micro. For a few minutes more. Thank you. So now, first process is define the process. You have to specify what is the problem about, how to define it. Then second one is you have to identify the data source. Second one is identification of data source. You have to identify what is the ideal data with which we can start with developing a model in artificial intelligence, may it be machine learning or deep learning. And the third one is you have to choose the technology. What is choosing the technology? Choosing the model. Right? What is the model that is suitable for solving my problem? So by doing it again and again, in due course, you will get a kind of intuition, right? This model will work well. But after finishing this, I'll give you a hint. Then choose the technology, and then you train artificial intelligence model, right? Training is the very important step. And then fifth one is after you train the model, once we are satisfied with the performance of the model, then you go for testing it. As you conduct the classes, right, you give notes and then give coaching, and after that you conduct CFA test, that's internal test 1, 2, then you go for ESE. So we have to test whether whatever we have trained has come out correctly or not. And then the next one is, once it is done, you identify some defects at the time of testing. They have to be corrected, right? We try to improve the quality performance. So improve the model, and then you go for check the results and deploy it. Okay, so now the third one, I think, choose technology, right? So now how do we choose the technology? Now please remember, whenever you are attempting to develop a model, you have to identify 4 or 5. You have to identify most important vital 4 or 5 models, and you use the your data set and try to get the results. So then from the results, you will be able to validate which model is the most suitable one for my data set. Right? Out of the 5, suppose if you want to assign a project to a student, what do? You just look at their marks. Those who have got 80 and above, you choose. Like that, you have got 5 models in your hand, right? So out of the 5 models, whatever that gives the best result, or 2 or 3, you have to take them, and then you try to refine it. Then you try to modify it, try to optimize it, try to change the model. So that is the only approach. Now normally what we do is, you decide to enter into artificial intelligence. Someone may just start with SVM, someone may start with naive-Bayes classifier, someone may take decision tree, and yet another person may take multilinear regression. This is not the right approach, because random forest may give a better result, because we do not know which model is suitable for the model that we are working with. So you have to take at least 5 or 6 models, try to get the results, and the one that gives the best result should be chosen, and then you have to fine-tune it. You should never handpick the model when you work with artificial intelligence or any kind of experiment for that matter, right? Okay, so this is about machine learning. Already we have seen what are the types of machine learning, and this is one of the classical definition given for machine learning. No other definition will be much better than this. So a computer program. What is a computer program? A set of code. Yes. In this case, we can take, say, linear regression, or we can take random forest, you can take naive-Bayes classifier, you can take support vector machine, k nearest neighborhood, k means cluster, any model, right? So a computer program is set to learn from experience. I told you, we learn from experience. So we learn from experience from different actions, objects, environment. So from where does experience come for a model? From the data, right? So it gets experience from the data. So it learns from experience E with respect to some class of task, right? It performs identification, then prediction, classification. So that is the task that it does. And for the particular task, we measure the performance, right? What is the accuracy? What is the error rate? If its performance at a task in T, right? That is the way in which it performs classification, identification, as measured by P, improves with experience. At the first time, I may get 80% accuracy for my cardiovascular disease identification. I refine it further. I make it as 90% with the support of this computer program. So this is what is being called as machine learning definition. This is by Tom Michel. Okay, so now we can just show it as a graph of various combinations like supervision, unsupervised learning, supervised learning, computer vision, recognition, object recognition, clustering, classification. These are all just put together. So machine learning is a subset of artificial intelligence that automatically enables a machine or system to learn and improve from different experiences. By going through different epochs, it is able to perform. Then, instead of explicit programming, machine learning uses algorithms to analyze large amount of data and learn from the hidden patterns, that is from the insights of the data, right? So, machine learning algorithms improve performance over the time, as they are trained or exposed to more amount of data. So this is again like what the machine does. It is repetitively, this is what we say. So ML employs a variety of, I told you, you should be thorough with statistical methods, probability, then linear algebra, and then some basics of mathematics. So it employs statistical probabilistic optimization technique. It allows machine to learn automatically from the past data. Then algorithms that can learn from observation data and can make predictions, right? It can make predictions, we have already seen. Then explicitly used to make decisions based on learned patterns, and each can go for development of an analytical model, or it can artificially find what could be the future prediction. Then what is the sequence? We start with data, we find the pattern, we take the pattern and train the model, then it trains itself and produces the output. So the accuracy of classification is highly influenced by, I told you, the diversity distribution of the data set. Okay. So the goal is to build machines that can learn from data to increase the accuracy of the output, and then we just go for training the machines with data to perform specific tasks and deliver accurate results. See here, there is one more point to be taken from the second one. What is the second one? Train models with data to perform specific tasks. What is that specific task? If I develop a model for machine learning, using machine learning for disease prediction, it can do only disease prediction. If I develop a model for weather forecasting, it can only perform weather forecasting. So when I develop a model using machine learning or deep learning, right, for a specific model, then it is not generic, it is problem specific. That's the main difference between generative AI and these models. So your deep learning, machine learning are being called as non-generative artificial intelligent model, right? Whereas ChatGPT is generative, it is not specific for disease prediction or anything. You ask any question, it is able to answer. So that is generic in nature. When the problems that you solve using machine learning is not generic, they are problem specific, right? That is why we call this as perform specific task. So what's the third point? It uses self-learning algorithms to produce predictive models, because every time it learns, as we learn, it learns. So we have discussed almost about all these things, but here I think we have got a set of detailed information about this machine learning with respect to supervised learning, unsupervised learning, reinforcement learning. I just leave it to you, right? As an extension of this, you'll be able to learn, because anyway this PPT will be shared to you. You can just get into the nuances and then read it. So the next one is deep learning, right? Overview of machine learning. We have finished. Now we are moving on to deep learning. Now, what is the need for deep learning? Because we are comfortable with machine learning, right? What is the need for deep learning? See, whenever you go for machine learning models, I told you about feature extraction. I told you about different pre-processing operations. So all these operations are to be done by us. Only the last component of disease identification will be done by the model. Right? One more thing I want to add at this point: when you are working with any kind of data set, right, please do apply the feature engineering techniques. Right? So data cleaning, data imputation, data curation, feature engineering. This should be the first part of your research. Right? So you meddle with your data set, make it as perfect as possible. Only then you can move on to selection of a machine learning model. Right? So when you talk about deep learning, this relieves us from the problem of doing this feature extraction manually. This feature extraction becomes a kind of inherited component of this problem solving. Right? So automatically it will be able to handle everything in a better way. So this deep learning applies multi-layer process for learning rich hierarchical features. That is data representation. Right? I think representation of a pixel. I think because you know how to represent a pixel in terms of 8-bit representation, 4-bit representation. So as we increase the number of bits, then the detail or resolution of the pixel improves. So now, when I take, how to put it, suppose if I have 10 pixels, okay, so for every pixel I have 8-bit representation, right? I have the 8-bit representation of the first pixel, then 8-bit representation of second pixel. I have arranged it one after the other. So how many rows will I have for the 10 pixels? 10 rows, each having 8 pixels. So for each and every pixel, I have least significant bit and most significant bit. So now when I take the LSB of all the 10 pixels, right, I'm just going to slice all the first LSBs, then, இப்போ எத்தனை மணி 3:50 ஆயிடுச்சா? இன்னும் நிறைய ஸ்லைட்ஸ் இருக்கு. ஓகே, இந்த டீப் லேர்னிங்கோட முடிச்சிடுறேன். So when I take the first slice of that, that is called as least significant bit plane, right? I can go ahead with the second plane with the second bit, third plane, fourth plane, fifth, sixth, seventh and eighth one will be the most significant bit. So as I look into the details, then the MSB will have very vital, most significant information, whereas because the most of them will be 0, right, in the least significant bit. So that will not have much vital information. So this kind of deep learning models will be able to look into the details of the data in a better way than deep learning. They learn deep into the data, and hence these models are being called as deep learning models. Right? So what is the definition? It applies a multi-layer process of learning, rich hierarchical features. There is no hierarchy, right? It is everything goes in one go, right? That is a flat learning process. But here what happens is we just go by, we give the input pixel, then it identifies the edges by itself, it goes for the texture, it goes for the parts, objects, then goes for object identification. Okay? So as we talk about this deep learning, the most important one to be learnt or to begin with is neural network, right? This neural network is designed based on the structure of your human brain. As it is connected by neurons, the same thing is being there. It's very interesting to work with this neural network. It has got 3 major layers as input layer, hidden layer and output layer, right? And in some cases, it is not necessary to have only one hidden layer. There may be multiple hidden layers. So as the hidden layer increases, then the complexity of the model increases, right? So depending upon the nature of the problem to be solved, depending upon the requirement, you have got more number of hidden layers. So when there is a single layer, it is called as single layer perceptron, and if there are multiple hidden layers, it is called as multi-layer perceptron, right? And this is like you have standard kind of operations for each input, weight is being assigned, then you go for summation of the input multiplied by the weight, right? x1 into w1 plus x2 into w2 plus up to xn into wn, right? And then there is some computation that goes on. Now when you do this kind of computation again and again, you get some kind of data which is called as unbounded data, where you cannot fix the lower value and the upper value, right? It becomes kind of assorted set of data. Now please remember, now as far as this machine learning, deep learning models are concerned, they need a threshold value, right? Suppose if it is disease identification, if the probability is above 5 or above 7 or above 8, disease is present. If it is below 8, disease is not present. So they have to have a concrete value. So when the data happens to be highly assorted, it cannot make any decision. For that purpose, what we do is we apply a function called activation function. Right? There are different kinds of activation function. I think you must have come across like ReLU, right? And softmax. These are all examples. So what is the purpose of these models? They try to convert the unbounded data into bounded data, right? Suppose if it is 0.005, if it is 0.5, 0.7, all will be changed into either 0 or 1. Okay, so we convert the unbounded data into bounded data. So what happens now? Whenever there is 0, disease is not present. Whenever it is 1, disease is present. So like this, it will be able to make a decision. So now this is what happens. Now there are multi-layer perceptrons when there are multiple hidden layers. So you have to just work with this artificial neural network. It is very interesting to learn and then work. I will suggest you to work with this neural network. You'll get good results. The next one is called as, for this we can have one complete session, right? Convolutional neural network. If you understand the performance of this functionality of this convolutional neural network, all the transfer learning models are based on the CNN and ANN. Right? So what is the difference between that ANN and CNN? Now this it is going to use a convolution operation. What is convolution operation? Dot product. Right? When I have two matrices, I take the first part, multiply with the first part of the next matrix. Second part, multiply with the second part. Dot operation, because it involves this convolution operation for as it has x1 into w1 in the case of neural network. Here it performs, it uses a filter or a kernel and then takes a small portion of the image and then it does the multiplication operation, that is called as convolution operation. So because it uses convolution operation, this network is called as convolutional neural network. See, now you have to understand like how it works. Then you can use, because otherwise it is just available ready-made, right? You have to just supply the data and get the result. So here also, whenever you just go for this kind of operations, now remember the size of your input image will get reduced drastically. Right? That process is called as dimensionality reduction. This dimensionality reduction itself is one research area. Right? How best I can reduce the dimension of the given input, provided I have to get the best accuracy. Right? When I go for dimensionality reduction, that should not spoil the quality of the data. Right? So I have to reduce at the same time. I must be able to maintain the integrity of the data. Right? That's very important. So here also we perform. You could see here there are a kind of array of filters being available. You apply them and these are all the results that you get out of convolution operation. Then this involves one convolution operation, then one activation function. Then the third row is called as, it is called as pooling layer. Right? What is pooling layer? You know, this deep learning extracts the feature by themselves. To extract the features, it uses this pooling operation wherein it will be able to extract the features by themselves. So now what happens is, if I have an image of size say 10 cross 10, so how many pixels will I have? An image of size 10 rows by 10 columns, 100 pixels. Right? When I construct a neural network, the last aspect of convolutional neural network is fully connected layer. This is actually neural network. You could see here, right? Whatever you saw here, this part is being used here. Right? So this neural network, here 3 dots are there now within this blue box. So that represents input. When I have an image of just 10 cross 10, I have 100. Right? When I have an image of 256 into 256, you can imagine the number of pixels. So as you have more number of inputs, the complexity of your network increases. To avoid that, you have to go for convolution. It reduces the number of inputs. Dimensionality reduction takes place with the support of convolution operation. Activation function will change the unbounded value into bounded value. And then you go for pooling. Pooling also further reduces. What is pooling? Out of the 4, I get the maximum value. Right? So after that, as the size reduces, then you give it to the neural network. Then the same process repeats. So this is all about this reloop pooling there I have told, and you can take this and then the same like whatever we have done there with respect to machine learning model. Okay, so let me not. So I have given what is the purpose of this, how do they work, how do the traditional models work, how do the machine and deep learning models work. I just leave it to you. Those who are interested can just work with this. See, now you can take the last one, right? What are the examples that are used for thresholding Fourier transformation as we have done in the traditional model? You can have CNN, GAN, transformers. Now the latest ones are transformers, right? GAN, generative adversarial network, right? That has autoencoders, transformers, variational autoencoders. These are the latest algorithms, right? GAN, Generative Adversarial Network, right? GAN models you can just write, and this GAN models have got autoencoders, variational autoencoders, and then transformers. So these are all the most important one, and when you want to apply your problem, when you want to find new solutions for your problem, then you can go for using those kind of latest models. So this is the workflow, right? How do you go about data acquisition and pre-processing? Now this is like you have to collect data. The data may be available ready-made or data you have to collect, and those who want to have a very novel research, right? You can have tie-up with some hospital, and you have to collect data, and you have to start preparing the data set with the support of a doctor, right? So what is the advantage? When you develop a data set by yourself, that becomes real-time processing, number one. Then there is one journal called Data in Brief. The journal name is Data in Brief, BRIEF. See, now when you develop a data set and when you produce results with that, then you can publish your article in that Data in Brief, right? That is the advantage. So when we talk about data acquisition, it is not essential that you have to always collect from the ready-made data set, available data set. You can think of going for generating on your own. Then feature extraction, engineering, I have told you have to work for check the validity of the data, variability of the data, authenticity of the data, right? Everything should be checked. And then I have given a set of transformation techniques. You can apply that and get the results. Then data segmentation. This is an interesting one that is called as augmentation, data augmentation. Now, suppose if you want to conduct your end semester examination, you must have completed the entire syllabus, right? Otherwise, how could you set question paper for all the 5 units? Like that, see, when you want the model to learn something, you have to have voluminous data. I have just 2 records. Can I make the model to learn? It's not possible. But there is a scenario, for instance, you have got very vital data, but I have only 100. To apply deep learning models, 100 is not sufficient. You want to increase it. In such cases, there are a lot of ready-made techniques available to be called as image augmentation techniques, data augmentation techniques. See, now suppose if you have an image, you can apply some transformation. You can rotate it, right? You can blur it, then you can sharpen it. Like this, out of the 100, you apply some 10 transformation technique. So 10 into 100, you can just multiply the number of inputs. So that is called as augmentation. That is also one of the important one. See here, there is one model called Generative Adversarial Network, right? This is an important one, and this is the latest one with the help of which you can go for developing synthetic data. So suppose if I have brain image, I'll be closing now very shortly, don't worry, right? Don't rattle the bottle, I'll be stopping in few minutes. Right? So now this GAN is the one, this model, right? If you give 10 images, it will be able to generate 100 images. So this is the model for data augmentation, right? You can use it. So then model selection, I have told you how to select the model, right? You have to take 4 or 5 and make it work, and then select the best one. Then you have to validate the model. That is very, very important. You have to look into the review of literature and identify. Don't meddle with, when you're writing a good research article, don't meddle with the good old metrics, right? Try to find out new metrics, or if possible, take it as an opportunity to come out with your own metrics, right? So metrics play a very important role when you go for result analysis and comparison and discussion. So pay much attention to the results that you get, and these are all the examples like cross-validation, hyperparameter optimization. These are all the important features to be included when you are working with machine learning, deep learning model. So then deploy it in a real-time environment, and then you deploy it, and after that there may be some certain corrections to be done. Again, it calls for revision, it goes again and again. And these are all some important like edge deployment, cloud deployment, on-device processing. I'll suggest you to go for all this kind. So continuous learning, like once you deploy it, you have to check whether it is performing well in all the kind of operations. Suppose if it is medical diagnosis, it may give accurate results for 8 patients, it may fail in 2 patients. So again, you have to go for improvement. And then online learning, federal learning, these are all examples. And then I told you how to select the right model, and depending upon the literature, depending upon your practice, you have to go for selection of models. They have given some use cases, and the recommended models are there. What is the task that you want to perform? You can take this as a reference. Then applications, you can use it in speech and audio processing, then biomedical signal processing. Already we have touched upon all these things. Then wireless communication, and then we can use it for security networking and many such things. And applications, I have given, like what are the use cases where you can apply. This you can take as an example to understand the performance. I think I made a mention about bias with respect to artificial intelligence models, right? When the data is not good enough, it leads to bias. It cannot, it loses the potential of being general in nature. Right? What is general? It must be able to handle any kind of cardiovascular data. When it works only for the children, when it is not working for the adult, then it is called as bias. So for which you have to have a better data set to perform all these operations. And I'll just leave this. What are the training challenges? And it has a lot of challenges when you train it. Now there is one more point called, there are 2 things you just write in your notebook. One is bias, other one is variance. When you work, 2-3 minutes, right? I'll just finish it. Bias and variance are 2 components to be taken into consideration when you work with artificial intelligent models. Now, at times, at the time of training, it may have 98% accuracy, whereas when you test it, it may give you 70% accuracy. So what is the problem? The data set that you have given for training is good enough, but that is not able to generalize it or adapt to the new data set. So you have to adjust the bias and variance of the model, so that you will get a kind of balanced model, right? So most of the researchers don't touch upon this, and you can, when you are writing a thesis or when you are writing your research article, you can give due consideration, due importance for bias as well as variance. So that is again a kind of measure to see how good, how balanced your model is. Right, future trends. Now we are talking about self-supervised and a few short learning, right? You don't have to have very lengthy kind of learning, right? As a smart learner, we have got models which can learn by themselves, self-learning models, self-supervised models, and then a few shorts model. Now this is a traditional deep learning requires large label data set, but self-supervised and few short learning models reduce the data dependency. With limited number of data, they will be able to produce better values. So then AI-driven real-time signal processing and emerging applications. So now this finds application in healthcare, right? And then in cybersecurity, in smart city, this is the upcoming project for many of the major mega cities, application of artificial intelligence in smart cities, right? So now you are very close to Coimbatore. You can talk to the corporation, right? If they have any kind of such action to be taken for smart city conversion, you can get involved and take some projects for smart city development. And then this is related to the wireless communication and IoT, 5G and IoT related problems can be taken. So to conclude, machine learning and deep learning are revolutionizing signal and image processing world, driving advancements in healthcare, communication, security, and smart systems. So despite challenges in bias, computational complexity, and ethical aspects, what is ethics? Now, when the doctor is giving a wrong decision, then you can go and sue a doctor in the court. But when there's an artificial intelligence model that is giving you a wrong result, whom are you going to sue? Is it the developer, or is it the one who has bought, or is it the doctor who is using it? So the accountability is not there. So this does have ethical considerations to be dealt with. Probably in the coming days, those ethical considerations will also be addressed. So despite challenges in bias, computational complexity, and ethics, cutting-edge solutions like self-supervised learning and real-time AI are paving the way for efficient, trustworthy applications, that is reliable applications. You can rely on a doctor, right? In the similar way, we are going to have models which are reliable. So AI continues to evolve its role in enhancing human capabilities and transforming industry or any kind of operation that becomes increasingly evident. So by embracing responsible AI development, we can unlock unprecedented innovations which I have not thought of before, while ensuring fairness, security, and sustainability. So the future of AI-driven signal processing is bright, promising smarter, faster, and more adaptive technologies are waiting for the better world towards us. So I'm done. So I thank every one of you for your attention. I thank the organizers for this wonderful opportunity. Wish you all the best, right? We have got a lot of openings, opportunities to be done with artificial intelligence as a researcher, as a student, as a faculty, right? I request you all to explore the possible research avenues and flourish, right? Because we have the statement, publish or perish, let it be publish and flourish. All the best to you. Thank you.
Ma'am, I have one question, madam. For example, is there any specific model for capturing the video, that is motion picture? For example, deep learning algorithms, there are several algorithms are there. Is there any specific model is effective to detect the motion images like video images? For example, any specific animal movement or something?
You have to design the model, right? You can choose the most important, any of the deep learning model. For instance, AlexNet, this ResNet, InceptionNet. Sorry, for want of time,